So for those of you that were gone on the overnighter, and I checked the logos today, some of you had questions on finding A. Your H and K were great. It was more finding the vertical stretch. For the rest of you, I went over this last week, but a lot of your logo projects were still missing this. Your H and K's look good, but you got to find that vertical stretch, and this is how you're going to do each function as you move around and kind of connect the dots on your logo. So for Brian, he wants to construct a cubic function that has a locator point of -1, 3 and passes through -4, 4. Find the cubic function that would make this true. Now, it's important to notice that for a cubic, the locator point is at 0, 0, or the point of inflection. So you'll have something that looks like this. The locator point will be right in the middle. Oops. Let's back up. Somewhere in the middle. So that's your locator point, which should be -1, 3. So this curve, in all actuality, will look something like this. It will start down -4, 4, it'll move up, and then it'll curve. Now, the rest of it will continue on and go off, but we're going to set a domain, so we actually don't need that part. So the question becomes, how do we find this curve? So, we know our locator point is -1, 3. So our locator is -1, 3. And we know also that our xy, or the point where we're going to have it stop, is -4, -4. So using that information, we're going to set up our general form for our equation. Y equals A x minus h. Since it's a cubic, we're going to the third, plus k. And we're going to find each part of this. Now, our locator point is going to be our hk. So -1, 3 will be our h and our k. So since we are moving one to the left, we'll have y equals a x plus 1 cubed plus 3. Now, knowing hk, this means I'm going to go 1 to the left and 3 up, which brings me to the locator point. That works. So now that we have used our locator point, we need to figure out how to use our xy, which is a point on the graph. And for that, we will just plug into x and plug into y. So now we can go ahead and write this again. -4 equals a -4 plus 1 cubed plus 3. Now the nice thing about doing this is now we can isolate a. In order to isolate a, the rest is all algebra. We'll just isolate the a by simplifying the algebra around. Make sure when you cube the -3, it stays negative, plus 3. And now we can subtract 3 from both sides. And then final move is to get that a all by itself, divide by -27. So final answer, a here, at least for the a, is -7 over 27. So now that we have our a, we can go back and write our final hk form with a, h, and k. Y equals -7 over 27 x plus 1 cubed plus 3. We got our shifts, 1 to the left, 3 up. That brings us to our locator point, and negative 7 over 27 is our stretch factor, which should make sense. We have a cubic that is, oops, actually it's positive. Excuse me, it's positive. Positive 7 over 27. Caught myself, so there you go. Make sure it's positive 7 over 27 because it's opening up. And a good way to check this is now looking at the shape of our graph. This is how I thought of it. You're moving up like this, but we are restricting the domain, that's the last part of this, to make it start at -4 and end at -1. And that will give us the part of the graph right to the locator point, and then kind of cut it off. So it looks something like that, which will fit the graph we're trying to form. So when you guys are doing this, make sure you are not only using your locator point as your HK, but you are using your XY to find the A stretch. So you'll be doing this for each function. If you're still struggling with this, I'm having a hard time getting started, come into office hours Tuesdays or Thursdays, you can get help. Alright, hope this helps.